Now friends, let's take this question. In a 12-story building, 3 persons enter a lift cabin. It is known that they will leave the lift at a different story. In how many ways can they do so if the lift doesn't stop at the second floor, second story, right? That means 3 persons are there. 12-story building is there. From one, maybe any of the floor they have entered the lift cabin, right? So suppose first person, if we talk about, maybe the 3 persons are A, B, C, right? Now the lift doesn't stop at the second floor, and the person are entering the lift from any one of the floor, right? So they will not, none of them will get out of the lift from the same floor from which he is entering, right? So we eliminated two options, that is the second floor and the same floor and the floor from which they are entering the lift, right? So A has 10 choices to get out from the lift, right? Or to leave the lift. Now B has, since all of them have to leave the lift at the different floor, so A has 10 choices, that means B has 9 choices and C has 8 choices, right? So it's 720. Or else from these 10 floors we have to select any 3 floors on which A, B and C will leave the lift, right? Now we have selected the 3 floors. Now the order in which A, B and C will leave the lift will be 3 factorial, right? 3 persons are there, so 3 factorial ways are there to arrange them. So 10C3 into 3 factorial, that is 10 into 9 into 8 by 3 factorial into 3 factorial, so it is 720, right? So you can go either way. This is the combination method and this is just the arrangement, right? So I think you are clear. It's 720. Now friends, let's see this problem. The number of ways in which 6 different books can be distributed among 5 students. Here friends, there is no condition given that one particular book is given to one particular student, or maybe all of the students should be getting books. That means no conditions are there, right? So there is how many ways will be there? Suppose there are 6 books, A, B, C, D, E and F, right? And the 5 students are there. Now suppose we take up the first book. Now we have how many options to distribute this this first book? That is 5 options, right? We can give the book to any of the 5 students, right? For the second book, we still have 5 choices. For the third book, we have 5 choices. For the fourth book, we have 5 choices. For the fifth book and for the sixth book. So for all the books, individual books, or for each book we have 5 choices. So in all there are 5 raised to 6 ways to do this, right? See, good number of students get confused, like it will be 5 raised to 6 or 6 raised to 5, right? Because various fundas are available on various books. Just give the smaller power to the bigger number or bigger power to the smaller number, right? But don't go with these methods, like these are just confusing methods, right? You just have to go conceptually. See, what are you distributing? That is the books, right? Now for the first book you have 5 choices. For the second book you have 5 choices. Write it like this, you will instantly get the answer, right? To get this answer, what will you speak? Just listen to me, what I'm speaking over here, whether this is valid or not, right? I have 5 students, maybe student 1, student 2, student 3, student 4, student 5, right? Now first student have 6 choices, right? 6 books are there, so first student have 6 choices, second student have 6 choices. Is it valid? No. Student doesn't have to choose the book has to be given to the student, so this is not valid. So we want to be getting this answer, right? So be very clear about the difference between these two, right? What you are going to do. See, there is number of students are there and you need to distribute the books, right? So for each and every book you have choices. For student, you don't have choice of books, but for books, you have choice of students, right? So you have to go this way. And what I'm doing over here, I'm just applying common sense, nothing else, right? No big mathematics or no big permutation combination fundas are involved over here, right? Be very clear. Now, similarly, there are 10 true false questions. The number of ways in which they can be answered is, right? Now, we have 10 questions. For every question, we have 2 choices. It's true or false, right? Suppose I pick up question number 1. I have two choices whether I will mark true or false. Then I pick up second question. I have further two choices, true or false. Then for the third one, for the fourth one, for the fifth one, till 10th one, right? So 2 raised to 10, right? The same funda I'm applying over here that I have applied in the previous question, right? Choice are where are choices that you need to think, right? You picked up the question, then you have two choices. So for the question you have choice, for the choice you don't have questions, right? So for the first question you have two choices that you will mark either true or false. For the second question similarly you have two choices that you'll mark either true or false, right? So till 10 questions you have two choices for each question. That means it's 2 raised to 10. Okay, it's very important.